Healthcare affects everyone. And so if we want to have an impact in the general population, we have to make sure not only are we training the very best physician and physician scientists, but through our research, we're able to develop real cures to some of society's most pressing diseases.
We have so much data now. All this information is being collected. How do we make knowledge from this data?
In the end, what we're trying to solve is capturing a patient's story. Wherever they go, whatever they do, without healthcare getting in the way of patient lives, but healthcare actually supporting patient lives. If we've done our job right, it ensures that the right data are available for that specific patient at the most critical time. We're ambassadors of information.
We have our research programs, but we also do a lot of service, and that's really helping other researchers kind of do translational science. A lot of that is reliant on data, and so how do we help researchers get to data that they might not have been able to get to before? We really get to interact with everyone from many different disciplines, clinicians, patients, biologists, public health practitioners, and really kind of serving as an interface.
It's really hard to translate those fundamental findings into actual clinical practice. And that's what BITS is geared towards doing, which is bridging those gaps across what we call the translational barriers. Putting the bench biologists next to the clinicians in a very thoughtful way that allows for us to make those connections. We've spent the last 2.5 years building pipes, but coming into year 3, going into year 4, data is going to start to flow. And there are projects that are going to launch that would never have been possible in our community 3 years ago.
We can keep alive a baby who is born halfway through the pregnancy almost. Up to 40% of all babies who are born very early develop what we call bronchopulmonary dysplasia. So this is a disease that causes these babies to have long-term problems with their lungs and also can affect their longer-term neurodevelopment. What I study specifically is looking at the impact of this oxygen radicals on aging in that baby's lungs. Some of the signals that are produced can cause cells to senesce, become old, and these cells then produce these inflammatory responses. We became interested in this aging in the lung because there are aging specialists who are right around the corner who are willing to collaborate with us, and that got us additional funding to support this work. None of this can happen in a vacuum, so the Alpert Foundation is essential to providing resources to make this happen.
Skin cancer is a scourge. There's sort of very, very sharply increasing trends in skin cancer rates across our country. We ended up doing some work looking at the association between people consuming citrus at certain quantities in their regular lives and their risk of cancer in the future. And what we found was that there was an increased risk of melanoma, about a 30% increased risk of melanoma. Turns out that citrus, lime juice, lemon juice, grapefruit juice, orange juice, all contain rich amounts of naturally occurring substances called furocoumarins. And furocoumarins make you burn in the sun. So it'd probably be okay to consume citrus in the afternoon once the sun's further lower down on the horizon, so you don't get enough sun exposure, and then it gets metabolized in your system overnight. Early morning citrus intake right before you're about to get sun exposure all day is probably not a good idea. Without funding from the Warren Alpert Foundation, it would have been very, very difficult to get started in the areas we've actually begun to launch efforts in. As you begin these research efforts, it takes a few years, and I think we're just beginning to now realize the fruits of that investment.
Epilepsy is the most common chronic neurological disorder, so it's 1 in 26. 30% of the patients with autism have epilepsy, and a high proportion of patients with developmental epilepsy also have autism. So we see, in the same person, both a neurological and a psychiatric disorder, and the biology underlying both of those has to be very similar. It just makes a great deal of good sense for neurology and psychiatry to have a combined laboratory and research presence.
The genetic progress in the last 3 to 5 years has been incredible. This has been true for autism, but it's also true for Alzheimer's disease, in that the genome-wide association studies, the GWAS studies, have produced a sizable number of very impressive hits. A child with a new diagnosis of autism or intellectual disability gets his or her genome sequenced, and they'll get a result in the clinical realm that will convey some larger part of the cause for that condition, a genetic change. This allows us to diagnose children and families in the clinic and also study the mechanisms of brain development in the lab. It's incredibly exciting because it allows us to, for the first time, follow the logic of genetics to try to understand the causes in autism and related disorders in a way that we haven't been before, because we haven't really had the ability to apply these genetic methods.
We're at the point where we really can do a lot more good. Between the circuitry control, all the stem cell work, and our understanding of genetics, I think the time is really ripe for real advances in neuroscience. We can say this really is important for the human condition, not for an animal model, not for something in the laboratory, but really for patients. It makes me really feel very hopeful. I think that by the time we're ready to wrap things up, the field will be much better than it is now, and the future will be a lot brighter for kids with epilepsy.
The whole focus of translational science depends on data and information, and the Alpert Foundation has been there from the very beginning and supporting all of that.
And it really has been the infrastructure for building these bridges between campus and the hospitals. It's brought a level of prestige and recognition for the work that's being done at Brown.
I'm in awe of all the science that's gone before us. Being able to be a part of that in any way is incredibly fulfilling and really inspiring.
Having the support from the Warren Alpert Foundation to allow us to recruit the very top people, to support them as they engage in cutting-edge research and teaching, allows us to not only support us in our mission, but also to bring other colleagues and other students to Brown.
I received financial aid in college, and that was the only way I could go to college. And I was only able to come here because of the scholarships provided. It was just able to open my world to things that I never thought would be possible.
To know that we're at the forefront of saying we're going to do the medical thing, but we're also going to stand out when it comes to research as well. We're going to stand out when it comes to supporting our students and supporting those next steps in their endeavors and their interests. What Warren Alpert Medical School does, it supports that other aspect of patients' lives. It says, hey, it's not only about medicine, it's about saying we want to support these programs that are going to be preventative health, so the patient doesn't even have to come into us, and we're going to expose you to these things.
Brown was throwing us opportunities and really just encouraging us. I think it's what makes Brown special is just the community of mentors that really encourage students to do everything that they want and everything that they can imagine.
By educating future physicians who are going to go out and take care of the population, by promoting exciting cutting-edge research on trying to address some of the most pressing diseases that our population faces, directly relates to the mission of this university to make a positive difference in the world through our teaching, through our research, and through our outreach.
We're making a difference for our community. We live here, and thanks to the Warren Alpert Foundation, we're really able to focus on doing it right and building a concrete infrastructure that will support our community's needs now and into the future.
We're at the early stages. There are these exciting new developments because it allows us to have a new powerful approach to dissect these complex, very challenging problems. But we need to tackle these problems. Research equals hope.